Hello learners, today we are going to see about wine quality prediction. So starting from 0 to 10, the features will be available and the quality will be just predicted by the model. So if it is 0 to 5, it is not a good. If it is more than 5, it is better one. So this is a one which we are going to have a libraries here. NumPy as NP has been just imported to convert your data into matrix. Pandas we need to make the data into a format like a Excel sheet or where the system can easily understand in the format of SQL or tables. Data can be made in the form of tables. Matplotlib is for printing the results. Seaborn is for having a what is this heat map and data sets. In our program, we are using this Seaborn to display a heat map. So heat map is a one which is going to tell you which are all the similar features. So next one is splitting the data by using a train text split. So pre-processing, this is for normalization. So this metrics we need to say what is the classification, what is this accuracy F1 score that will be coming from this scalar. And SVC is a super support vector clustering. And another classifier XGP classifier and logistic regression. So three classification we are just concentrating here to have a prediction. So this is a data set values. So first 1 to 10 we are having the features. So fixed acidity, volatile, citric, residual sugar, chlorides. So this is the deciding factors for a wine. So we are reading this wine quality to a variable called df using pandas. Read CSV in an pandas library. And this is a readily available data set, wine equality data that will be available in a Kaggle. You can just press add data here and you will be getting all these things. So we can just run all this, run and run all. So it will take some time. So df.info is going to tell you how many columns of data which have been available, and describe is going to tell you what is a maximum number, what is a 50% of a maximum number, 25, 75, minimum number in the features that will be deciding factor when we are going to carry out the analysis part. And we can just see if we are having any NaN values, that is not a number. So we can just count that respective NaN value. So this is the where read CSV, it is going to read and it has been stored in DF. So we are going to display the heads of a column, type, fixed acidity, volatile. So type, we are having two types here, red and white. So we are going to differentiate it by using numbers 0 and 1 in the next lines of a code. So this one has so many features which have been available. Info is going to tell you what is the type of a data and how many non-null values, that is fully numbered values, you are having in those many features. So you can just see here what is the type, what is the features, what is the quality and all. So describe, as I've been told you, in a fixed acidity, how much non-zero value has been present, what is the mean value, standard deviation, minimum of this fixed acidity value, 25% of it, and what is the maximum value of fixed acidity has been present in the respective data set. In the same manner for all the features, this describe function is going to give count, mean, standard deviation, minimum value, 25%, 50, 75, max. So here we are going to search for not a number, or if the data set is having spaces, or accidentally if the researcher have been not given any of the values to the features. If so the case, we are going to count it. What is the NaN values in any kinds of features. So in fixed acidity, we are having spaces or not a number as 10. So we cannot leave this spaces, and we are going, or if we are going to train with spaces, the model doesn't accept. So we are having two things. One is make the spaces as 0 or make those spaces as sum or mean of a neighboring columns. So that is what, instead of making it as a 0, we can make the feature values based on its neighboring numbers which have been already present in a data set. So here we are accessing the column and we are saying which number which row is having an NaN value. In that row, what you are doing is fill it. What you are filling, you are meaning that respective columns data. So if the space is at second, and it is going to take the next and previous values and it is going to make a mean. So after meaning, we are again checking it if we are having any null values. So it is going to provide, okay, it is saying some error here. So this is called as an spacing error or indexing. You need to provide proper spacing. So if you need to write a code in an Python, so there will be no flower brackets. So what are all the things with one space? So the system or compiler will understand that for is going to be executing till here. So till these two lines will be executing. So this is one space ahead. So if is going to run, if this condition is true, it is going to execute this mean value, or else it is going for next column. So that is the meaning here. So after having a NaN values, or meaning the what is space values or which have been skipped by the modeler or researcher, so we have been just made a mean of it. So we are not having any NaN or spaces. So then again we need to run all, or else it will be taking time to run step by step. So this is a histogram of a continuous data, like fixed acidity, it is having some values, volatile acidity, what is this, sulfur dioxide, density. So this is a continuous data of how exactly the ranging of values have been more, it has been repeated with respective which have been provided in the y-axis. So this is x-axis and this is y-axis. So in the x-axis, it is going to give you the range of numbers, and y-axis, how many times that has been repeated. So this is quality of wine which are being graded from 0 to 9, that is 1 to 10. So this is a wine ratios, and this is a quality. So this is a heat map I have been just discussing. We are using Seaborn for this respective heat map generation, that is SP. So if the two features is having a similar characteristics, then there is no need to train two separate features. So here you can just see this free sulfur dioxide and total sulfur dioxide is having a similar characteristics. So if the values is more than 70% similar, more than this value, then we are going to correlation. That is, the correlation is a value which will be ranging from 0 to 1.0. If it is more than 70, we can just decide that both the values are similar to each other. So instead of training both, we are going to drop one thing. Total sulfur dioxide has been dropped. So that is a row wise. Axis 1 means full row of this total sulfur dioxide will be removed. So in order to do that, drop is going to be used. So this is again the pandas function, df dot drop. So we are just making a number here, best quality. If x is greater than 5, then it is a best quality one, or else it will be going to a 0. So whenever the value is more than 5, it is 1. Value is less than 5, it is 0. Okay, that is going to be just copied or implemented in a database. So we are going to replace the value white with 1, red with 0. As have been discussed here, two categories of wine will be there based on the colors. So we are having the quality and best quality in the row. So all these features target means the quality, that is the last row. Test ratio is 20, and the random state. So what is this random state actually says that whenever we are taking a data or training a data, every time the data will be shuffled if this random state is having some numbers. So if this being turned to 0, then there will be no shuffling while taking the data. Every time the model will give the same accuracy. So here the ratio we have been maintained is 80 is to 20. 80 is for training and 20 is for testing. So if you are having 1,000 data set, 800 will be for used for training and 200 will be used for testing. So here is for normalization of a data. So here we are having three models: logistic regression, XGBC classifier, SVC, and kernel is RBF. So it will be like cone-like structure. So the things which are being coming inside the cone will be considering as one class, outside the cone will be having another class. So we are fitting the model for X train and Y train for three classifiers. And we are going to provide you the training accuracy and validation accuracy. So training accuracy for logistic regression is 70, validation is also 70. So in the same case, like classifier XGB or XBoost, training is 97 and validation is 80. It is not a very good one. Like validation should also be hand in hand. So for SVC, training is 72 and validation is. So at last, we are going to have this classification report, which is going to give you the precision, recall, F1 score, and what are the support vectors which have been generated for 0, white, and red 1. So it is giving a precision of 80, recall is 72, and the average accuracy by the three classifiers is 83%. And the F1 score is 75 for 0 classes, and for a first class, it is having 82. So this is like how we are going to predict the wine quality by using the numerical data. That's it for this video. So we have been just learned how to have a how to use the data set which have been already available in Kaggle, and how to invoke or how to import the packages, and how exactly the splitting of a data which is going to happen, how to train, and how to see the accuracies. So that's it for this video. Thank you.